to Óscar Esteban. He works at the radiology service of the University Hospital and the University of Lausanne in Switzerland. And wow, I mean, he's the type of person that makes our lives much, much easier. As someone who has worked with Fmri data for a few years, I have to say thank you, Oscar, because it can be so overwhelming when you first start an MRI project and you realize about all the possibilities just in the pre-processing stage. All the little options, all the subtleties of the differences in the analysis, and you feel like you just don't know enough to make an educated guess and choose a pipeline. So it's very reassuring to have someone who simply just knows better about it and that takes the time to help others and ease our way into these pre-processing steps, especially. So, you know, guys, if you care about computational reproducibility and want to minimize the source of variation in your methods, I recommend that you pay attention to what Oscar has to say. So I won't take much of your time, just the floor is yours.
Well, thank you so much, Daniel. It's been a really nice presentation from your side, and I really appreciate your words. I'm not really sure if I know better than anyone else, but I definitely see, and I will actually tap on all those things you were mentioning about how overwhelming it is when you start in this field or any other field. And it turns out there's a lot of literature to go through, and even more worrisome is that before you can even play with your data and run anything about analysis, there's a lot of stuff to do before, because otherwise your analysis will get you nowhere. And that's even more difficult because you will need really a lot of expertise in many directions. So thank you for this introduction, and let me present the next hour and 15 minutes of the Brain Hack. Thank you very much for inviting me to and allow me to talk about this new little project we're trying to put together. It's called niPreps, which stands for Neuroimaging Pre-Processing Tools. And basically, as I will definitely say several times along this talk, this is some kind of generalization of the Fmri prep tool, which is a pre-processing workflow for Fmri, trying to follow the same patterns and same principles in other modalities. So without any more delay, I'm going to get this kicked off. So let me start giving you some outlook of what I will try to tell you. The first, in the beginning, I will try to dig up into the concept of pre-processing, why it is necessary, and I will try to do it starting the same way I did 5 years ago, starting from Fmri, so functional MRI, and then see how that generalizes.
Oscar, people say that they are not seeing the screen, so maybe you can try to reshare like again.
Okay.
Sorry
about that.
No. So can you share again?
Yes, I'm right now sharing it again. Can you see it?
Can you say something from? But okay, it seems like now it's working better. Thank you, Oscar.
Piling messages on my chat. Yes, thank you. All right, cool. Let's go. Cool. Perfect. All right. So my first step would be pre-processing from the Fmri side of things. Then I will explain a little bit about Fmri prep and how it hooked up. Then I will also mention the first iteration in this journey of expanding things and making them work beyond Fmri. and that would be with niPreps, which is the parallel of Fmri prep, but for diffusion MRI. I want to make a quick stop on one item. We've put a lot of importance in Fmri prep in the context of Fmri prep, which is the visual reports. And I will show you how this report pre-processing in general, and also in particular about your data. Finally, I will at last introduce niPreps as a framework, and finally, and after that, I will change the format of the presentation, and I will ask you to be more dynamic because I will go through the documentation of niPreps and some elements you can basically check out before you decide to start contributing. So. Needless to say, I'm happy if you cut me and raise your hand and ask questions all along the way. So let me start with this panel. This is a flowchart of basically it's a very representative of almost every Fmri analysis experiment. So I don't know if you see my cursor. Maybe. I don't know if you see my cursor. Anyway, on the left, you see this circle. We start from the scanner, and thank you, Aneko. And of course, we have a range of pills, sequences, and MRI schemes. These data then are formalized into some key space formatting. Some unit inside, typically inside the scanner, but sometimes outside the scanner, will process this key space and reconstruct some 3D, 4D volumes or 2D images, whatever. And then after that, you change typically some pre-processing. Basically, this stage of pre-processing will account for typical artifacts that happen while you are acquiring. So, for example, the typical Fmri acquisition will last for some time, and over that time, it's very likely that the subject will move, independently of how much collaborative they are. It's inevitable to swallow at some point, or blink, or do any kind of motion during the scanner. So you will want to account for head motion. All the things are artifacts that come from the actual MR scheme. For example, EPI, echoplanar imaging, is typically affected by nonlinear distortions that basically warp the shape of the brain. And you will also account for this during pre-processing. All the things you can also maybe do during this step, and I will go deeper into this later, might be, for example, adjusting for lags in the different timing of each of the slices in your dataset. Anyway, only after you have accounted for all these problems, you will be able to put together all the measurements you've taken. So typically your imaging data, but also maybe oxygenation information or heart rate or any other information. And also you will have some, you will also plug in your experimental variables, for example, the timing of the events if you are doing some kind of task with MRI, and put all together into a model. Finally, after that model is run, and if it converges, then you probably get some scientific output you want to publish. And as you can see in this little balls here, these are the symbols. This is the icon of or the logo of BITS, which is stands for Brain Imaging Data Structure, which is a standard to organize our data. So you can use that standard to communicate from these boxes to the pre-processing. And then this one in red stands for BITS derivatives, which means the black ones are for data that comes from the scanner or acquisition device, and then the derivatives are for data you have modified after some processing. So this is basically the big picture of Fmri today. And this is the picture of Fmri, of an Fmri experiment back in 2006, so 15 years ago. Yes, it is exactly the same flowchart. I just replaced these little labels here for the bits logos, and then I removed this SPI label at the end here, because at that point, Professor Strother meant statistical parametric images by this. And I think right now we have a lot more models that maybe output other different types of data. But other than that, all this flowchart is still valid. It is probably very surprising, right? Because it's like, okay, we haven't moved in 15 years. But I think that would be not true. There is at least one thing that has happened, very, very important. And this is bits. With bits, we've been able to give a consistent interface to the scanner, basically. So we can see this blue frame delimitates what the scanner, or maybe the scanning room, because there are other devices maybe attached during the experiment. But basically, bits gives you an interface that is very, very regular to all the data you acquire during the experiment, right? And then that makes it so much easier to build up preprocessing tools and data analysis models that it has really, really changed the game. And I also loved from this chart when I saw it in the 2006 publication. I loved these two different arrows on top and below, saying how, you know, changes in the technology, for example, a new acquisition sequence can propagate and improve the whole flowchart towards that direction, giving us in the end better maps, and how better experiments and better paradigms makes us they make us think about improvements at all the steps in the process, and maybe come up with better sequences and reduce, for example, the repetition time in our sequence, allowing us to acquire more information in less time. So I believe bits has opened a new age of progress in terms of technologies and methods in neuroimaging. In other words, neuroimaging is now in a stage pretty mature. We have a lot of tools available to implement the different boxes I've presented in the previous flowchart. And you know probably some of them or all of them, like AFNI, ANTS, or TreeSurfer, FSL, NiLearn, SPM. We also have some workflow software. I particularly love niPreps, and I embraced it since the beginning. I can totally relate to all the concepts Stefano was mentioning in the previous talk, because back in 2012, I was starting to contribute to niPreps, and I faced all those problems and issues and uncertainties Stefano was mentioning. And finally, we also have container technology, which can help a lot in the development of new tooling. We also have a quite wide wealth of prior knowledge, typically in the form of atlases or templates, and especially about humans. And then we're acquiring a lot of data every day. So in this context, bits surfaced roughly 5 years ago. And as I was mentioning before, it supposed a real trigger for new developments for mainly two reasons. First, it's very uniform. So the workflow, you can place any kind of code after a bits interface, and it would be relatively easy to interpret the data and have access, make a good idea, a good guess of how this data set should be processed. And the second thing is it's very complete. So it automatically can allow you to check whether the data set has all the parameters you needed. Do not ever write down manually the repetition time of your data set before processing, because that's prone to change and error. You might change the timing parameters from your former study to the next and vary it by 10% and forget. If you have to do it manually, then you're doomed. And then the second facet of bits is that it gives you a really easy and extensible reproducibility almost for free. Once you go through the pain of putting the dataset into the format, it's really easy to write software that generates bits derivatives, and it's really easy to follow the guidelines of bits apps. So there you will have in the presentation, which is, by the way, I didn't mention it, but it's online on the link in the first slide. So these two links give you first the website and second the paper where the bits apps are described. So now all this tooling is changing how we evaluate and think about our experimental infrastructure or tooling. We need to think about validity, whether the software is doing what it says it should do. We need to think about transparency. Is it a black box, or it precisely reports what is done underneath? We need to think about vibration problems. So how little variations in parameters or alternative tools will finally affect the output. We will need high throughput. We want to process a lot of data nowadays. And that also comes with robustness, because data will vary between studies, and you want to be flexible. You don't want to be attached to the Human Connectome Project guidelines and protocols forever. You probably need to change things. And finally, it changes the way we evaluate whether things are okay. And most importantly, we need to think about whether there is any alternative. All of this has moved the problems in neuroimaging to the garden of forking paths. I like to mention this paper by Rotem in the beginning of the summer. It came out, and basically they had 17 independent teams to analyze the same data, and basically they got the same answer, the 70 answers, which is pretty worrisome. If there's some light in this, is that 50% of the teams used data pre-processed by the NNARPS, which is the name of this project organization, and they pre-processed the data with Fmri. So to me, this means like, well, if you fix at least the pre-processing part of things, you are not fixing the problem of methodological variability, but at least you will have less degrees of freedom to make mistakes. So let me move on to the description of Fmri-Prep. Fmri-Prep is a tool to transform Fmri data as it comes from the scanner into something you really can plug into some modeling or statistical analysis tool. Fmri-Prep is designed to have minimal requirements, and probably the only requirement it has is to be for the data set, for the data to be bits compliant. And you can easily check that with an online validator that Bits has. And this validator will not upload the data anywhere, so you should not be worried about leaking your data. And in a few minutes or seconds, you can check whether your data are looking good. The second objective for the workflow was to be agnostic to any type of analysis you want to plug in afterwards. So if you think about the first flowchart, one of the experimental or analysis design variables that were at the bottom could be, for example, smoothing. Depending on the statistical model you're going to use, you will need some type or width of smoothing. And because of that, Fmri will not smooth your data in order to allow any kind of analysis to be run afterwards. And finally, we wanted a tool that was robust against any type of data set, and whether the data set was missing certain imaging modalities for a single subject because something happened that day during the scanning and you didn't have field maps. So Fmri should be robust enough to deal with that, and also changing data sets. So to make it easy to have different acquisition protocols, because you have different scanners in a multi-site kind of study. Then we wanted it to be a bits app. This was some kind of requirement because we wanted to deploy it within OpenEuro, which is this portal to share data with other researchers. And Bits apps was the way of abstracting out the concepts about any pipeline and make it amenable for automatic execution. And finally, we also needed to minimize or completely remove any human intervention. And of those who have used Fmri, probably you didn't have to set up many arguments to run it. It probably worked out at first without a lot of configuration. This is because we want to avoid setting parameters manually. And it's possible because the dataset adapts, the workflow adapts itself to the data that is coming in. In the beginning, the project was not a community project. We just wanted this very robust tool to work on OpenEuro. But we were surprised, maybe in the hindsight, not so surprised, but it surprised us at the moment that a lot of community built up very quickly. And in hindsight, we have at least 3 key factors. Probably these are the 3 most important. Preprocessing was a need for the field because, okay, I'm really, okay, there's a question. I will take it later. Preprocessing was really necessary, and I was, as Daniel was introducing in the beginning, when you start in the field, you don't know about everything. And if you were given the data ready for analysis, you probably will make a lot of progress more quickly because you will not need to be thinking about whether this preprocessing is good or not. You can trust it, and I will then give more reasons about why you can trust it. The second point is that we were obsessed with the transparency of the tool. We knew that making the tool transparent was necessary for people to be able to adopt it, because if the tool is not transparent, you better don't use it, because it could be doing things underneath that you don't know, and that is very risky. Finally, we tried to open as many channels as we could and try to organize ourselves to reply to everyone. So we had actually one day a week on call each of the members of the team to be addressing questions that arrived via email or in the GitHub repository or in Eurostars. and we were always trying to give an answer. And sometimes these questions were about problems of the software and things that didn't work out very well. But other times they were very, very plain questions. And I think that built some trust on what we were doing, because we were answering things outside of the, area of Fmri prep. We were giving general advice in neuroimaging to people. Another key aspect, and Stefano has tapped on this before, is crediting everyone. And we consider a direct contributor anyone who has talked to us, suggested something, of course, given us some code or documentation. All the people in this list have done something for Fmri Prep or its community. And this kind of lists of people is maintained up to date and recalculated with every release. And I say release knowing that Stefano introduced it in a very nice way before, with every release of Fmri Prep. And there's also a concept of crediting indirect credit, which is which we call with the citation boilerplate. Every time you run Fmri Prep, you will, in the end, add a excerpt of text with describing everything that was done in the workflow, mentioning the tools that were used, mentioning the versions of those tools that were used, and also citing any relevant paper for those tools or templates that you used. So to wrap up, researchers, they want to focus on inference, and that's what is actually relevant, and it's totally understandable. This is not to say there's no people working on new methods, of course, but still, most of the people are trying to analyze this difficult data. So preprocessing, standardizing preprocessing might be a good way of removing that burden off of there. Then, as I was trying to mention in the beginning, I'm not particularly the best expert on Fmri. I'm actually kind of a newcomer. Fmri Prep is the result of the expertise of a lot of people, starting from the head of the Poldrack lab, Ras, who was the candidate person to fund this initiative in the beginning, to every single contributor. All of them have shared their expertise and made Fmri Prep the tool it is now. Then transparency was crucial. Super easy tools, and I made a comment regarding graphical user interfaces before. Graphical user interfaces make things very easy for us. But when things are easy, the threshold to make a mistake is also low. So even actually, there was some discussion in the past with, I will introduce some abstract he presented, Jesse Wright. I usually mention him in my talks. He is a philosopher and was working with us in the Poldrack lab. And he was in favor of even adding some friction to the interface to make sure that the user suffers just a little enough to care about how you are running the tool. So in the end, it is important that things are easy, but it's also important that you, at the same time, make sure you report everything and make sure the user is aware of everything that has been done. That's very, very important. And finally, another principle is that we have a lot of tools out there, and people are doing an incredible job at maintaining them and keeping them up to date and fixing bugs. So it's better if everything goes that way. So I wouldn't expect from people who are right now concerned with the details of a registration algorithm, I wouldn't expect them to worry about big workflows. I'm not saying they shouldn't try or do it, of course, but I'm very, very happy if they told me, look, I am just focusing on this because this is important enough. Yes, I agree. So FMRI wanted to put together all these existing resources. And this is how it looks, basically. There is, on the left-hand side, there is some anatomical pre-processing. This is typically done on T1 images, which are here, and then you can maybe have T2 weighted images. It will take it. Steps here are usual suspects in the anatomical images processing. And the main results are a transformation to standard spaces, one standard space or more, some tissue segmentation to inform some methods in the functional MRI side of things that use this information to denoise the data. And then surface reconstruction for those who want to analyze their data on the surface. So this anatomical information is projected into the bold space. And for now, FMRI only runs bold functional MRI data. And this is how it looks, the pre-processing for FMRI. At the beginning, we generate some reference. This is just a 3D map that we can use for alignments of data. And for example, in the head motion step, which is next, we use this reference to align all the different time points onto this reference. Then we might run slice timing correction if the slice timing information is found within the bits dataset. There's a step for susceptibility distortion. There's a step for aligning to the anatomical data, because otherwise you can't really project this data onto the bold, these structures onto the bold space. And then this is the final steps of resampling the signal and generating the final product that analysis can take. Basically, a new signal with all the artifacts accounted for, and a list of time series of confounds that you can use in regression. So let's move on to TMRI. So the development of DMRI was triggered when Anisha Gasaban asked when we will have a DMRI prep tool for the lovers of tractography. And basically that happened in neurostars.org. I would like everyone to note this website down, because a lot of neuroscience is happening, and most of the feedback we receive from Fmri and all the support we give, we try to channel it through this forum. It's some kind of a Stack Overflow. If you know about, if you're a bit of a geek, you will know that Stack Overflow is like this big, huge forum for programmers to find their questions. Typically, the joke is everything is already solved in Stack Overflow. So neurostars.org is our particular community nest for neuroimagers. And we were working on this DMRI prep tool, and Gary and I went to ISMRM and had the pleasure to attend this beautiful session by Jelle Verhaert, where you have the link down below, and I'm just taking out one of his slides. And basically, we realized that the same problem we had been facing for Fmri was happening the same way, exactly the same way on the diffusion world. And he basically made this wonderful walkthrough all the steps of pre-processing on diffusion MRI. and whether a clear agreement could be reached very easily. So you can see steps 1, 4, and 5. This represents, for example, head motion. I don't remember right now the mappings, but it could be head motion and susceptibility distortions, for example. Those green balls are places where we easily will reach an agreement. And then orange is, well, there's some agreement, but we also need to figure out things. And red is where things are very different depending on where you are practicing, right? So this was just more evidence that we definitely needed some DMRI prep. And this is basically an equivalent to the previous flowchart of Fmri prep, but for the DMRI prep. We are currently working very, very hard on this, and there will be a tutorial by Michael Joseph, I think it's Thursday. So we are actively trying to join more and more developers interested in diffusion for this project. Now, let me change gears a little bit and try to emphasize why we are so obsessed about visualization of the results of Fmri prep in particular, but this also stands for DMRI prep, and it actually generates similar visual reports. So let's start this over again. This is an example of the individual report. And first, we start with a summary indicating the particularities of this data set and workflow choices made based on the input data. In the anatomical section, it follows the several visualizations to assess the anatomical processing steps mentioned before. Spatial normalization to template. You can see now a flickering panel between the individual and the normalized space to assess registration, and finally the surface reconstruction. After that, all functional runs are concatenated and all show the same structure. In the beginning, a summary saying what is this particular run, the alignment to the same subject anatomical image, and you can use the contours to follow as a key to see registration. Then the ROIs for some component denoising, and some relative plots about this kind of particular denoising of Fmri data. And after that, the next run. After all the functional runs are presented, there is an about section that keeps tabs on the details to replicate this work, these results. So you can see the software version on the OrderExat command line. And after that, the boilerplate I was mentioning before, there are several versions, one of text, and then you have Markdown and even LaTeX to copy and paste into your paper. And finally, the report finishes indicating if errors happened. So I always like to highlight, and this is the work I was mentioning before from Jesse Wright. These reports are crucial to assess whether Fmri prep worked well, but they are even more important to tell the researcher how the steps were run, which order, and what is the goal of each step. So this is more general, because this is information shared across any individual you run through this workflow. So by using Fmri prep and screening the reports, you will learn what this pre-processing means, what are the steps and the details. And with no more delays, I want to introduce niPreps. And I'll start by saying that niPreps, the goal is to augment the scanner. It's like pushing the blue contour in the original flowchart a little bit farther after the beginning of pre-processing, so that even the scanner produces analysis-grade data. And what does analysis-grade mean? It means that you can basically, your analysis can digest. It can consume this data directly. We like to use this as a metaphor for juicy grade data, because in both cases, the product is minimally pre-processed, but safe to be consumed. And we followed a process of deconstructing Fmri prep, which was a bit cohesive piece of software. And if you know a little bit about software engineering, cohesive is not always a great feature for an individual piece of software. And we came up with this map of tools. You can see at the top of the pyramid Fmri prep, which is from where we took all these different small pieces. And at the bottom, there is the software infrastructure, the most basic packages that we use. You can see, for example, bits here and PyBits, which is an implementation in Python to very easily query bits datasets. We have niPreps, which is a Python package to access nifty images and other neuroimaging formats that we use. So basically open up images. Then niPreps, which is the software framework for workflows, is the workflow engine. And then we have, if you look at the rest of the projects, they are inside of this brain silhouette. And this is because these are actually the projects under the umbrella of niPreps. Okay, these are these three projects I've just mentioned are very basic to understand the niPreps idea, but they are outside of this community because they have larger communities and around them, and they are definitely very important for many other projects. So I will quickly introduce all these little pieces of software. All these pieces of software are things where you can contribute and join forces with us, and definitely they will help you implement new things. One is niTransforms. This is a project that we started split off of niPreps, but at some point we are planning to join into niPreps here. And it is to handle the different spatial transformations that neuroimaging packages generate to align things up. Template Flow is a repository and a client to access templates. I will get into more details later, but basically it brings the templates to your implementation in a very, very easy way. My workflows at the moment is kind of a catch-all box where we put things we don't know where to place, but that we feel it will cater to some other higher level packages. Then I will skip crowd MRI QCNets and focus on SDC flows, which is the susceptibility distortion correction workflows package. I will describe it later. I will skip MRI-QC, talk a little bit about Fmri prep as the anatomical side of processing for both Fmri prep and DMRI prep. And then at the top, we have Fmri prep and DMRI prep. There will be in the future some other preps like ASL prep. So let me get started with the first of the tools. I think you have already learned about bits. If not, I really encourage you to catch up as soon as possible. It's really easy, and they have a starting guide, really, really useful. And I think I hope I have convinced you about its importance at this moment. Then with bits, one tool we always use is this PyBits. This is an implementation to query datasets, and as you can see in this example, you basically point it to where your data is. So right now we have all our MRI data under this cool project directory. And once it is this dataset is indexed, you can start making queries. For example, tell me the subjects in this dataset. And here we have 5 identifiers from 1 to 5. This dataset in particular has 2 sessions. And oops, sorry about that. And there are 2 tasks, resting state and back. Then the complement to bits is bits derivatives, and this is the format where Fmri and niPreps write things out. This is an example of how the folder tree that Fmri creates looks like. Everything about bits and bits derivatives is in the website, so please look it up. Then regarding bitsapps, I mentioned before the paper and the website. It basically abstracts out neuroimaging workflows and gives you some guidelines of how to go through the problem of writing one of these workflows. And one of the most important facets of this is that all these bitsapps have this common interface. So once you learn how to use one bitsap, you probably know how to use all of them. niPreps is the workflow engine, and it basically concatenates all the little pieces from all the different software tools we use. Fmri and SciPy, Surfer, all of them. And cares for the execution, making it amenable to running in clusters or running in the cloud or in your laptop. Then niPreps is the tool to access neuroimaging data in some of the neuroimaging formats. And here, for example, we are fixing the headers of a Nifty file. And then we start with the tools that are actually covered by niPreps. niTransforms is the simplest one. I like a lot this particular project because it brings me to the very basics of imaging. And it's really interesting to see how every tool implements spatial mappings in a different way. So the idea here is that this tool will be able to open any kind of transformation, say affine or maybe nonlinear from any package. So maybe you calculated one step with FSL and the next with Fmri. By default, those 2 transforms will not be compatible. niTransforms will be able to read both and apply them together, or write one single file containing both. Template flow is this big archive of templates that, well, it basically has the archive part and then the Python client. The archive part, you can see here on the right-hand side, there's, for example, one template here, this WHS template, which is a rodent template, expanded. And it has a bits-like structure for naming. And it gives you several files. Some of them are templates, like this template I'm underlining right now. They are represented with this brain. But there are also, for example, masks. There are segmentations or parcellations. And there is also, not here, but there can be some other, yes, for example, metadata here. There's several formats you can store. And it is queried almost in the same way as you would query a bits dataset, because we also use bits underneath. So, for example, here, this will get us the T1 template from FSL, which we use this code name. And further features of this is that all the templates are referred unequivocally. So basically, there's only one template for one name. One big problem right now in the literature is that you might be told, okay, the results are given in MNI space. In reality, it doesn't tell you anything because there are so many MNI spaces to the point that this particular MNI space is not found in the download download page of Fmri, because this is internal of FSL. It was developed by Andrew Young in a short stay at Fmri, but this template is not part of the portfolio of Fmri, and yet it is referred to it as Fmri in many, many instances. Depending on the version of SPM, you will be using one Fmri space or another Fmri version. So template flow aims to end that ambiguity. The archive can hold a lot of data. I am not going to go through this, but be ready, because we will try to take out the paper as soon as possible. We are in the last stage of this preparation. My workflows is this catch-all box. There are important things. For example, the reportlets. Reportlets are these units you've seen in the report. Every panel we generate is called the reportlet. And we also have the reports system, which is shared between all the preps. So niPrep, Fmri, both use the same report aggregation system. There are some extensions to niPipe where we experiment with them and maybe upstream them to niPipe. And we also have some workflows that are useful for many applications. SDC flows is this package to address the problem of susceptibility distortions. So if you look at this flickering panel, maybe look at the ventromedial prefrontal cortex here, and you can see how before, look at this label here. So when it writes before, it is deformed. And then when it writes after, the data is better fit with the contours in blue. And you can see it very clearly, for example, here at the genu of the corpus callosum, when before correction, it's not well fit, but then after it's correctly fit. Some other tools that are not in the big brain map I plotted are niBabies, which is an extension of Fmri Prep for babies, and niRodents, which is obviously for rats and mice. To summarize, to wrap up, we are putting together a framework for developing neuroimaging pre-processing workflows. That means it doesn't really need to be MRI. All of them share the same principles, and they try to leverage the existing tools as much as possible. And we try to limit it to pre-processing because we think that's a common place where we can arrive to some agreement. We try to minimize the methodological variability issues without changing too much the final outcomes. And it's easier to make it more transparent. In addition, if analysis methods evolve, but pre-processing doesn't really evolve, and as we have seen, it is already very mature. So basically, we have most of the tools we really need. It allows for a more for a faster iteration in development of new methodologies. And finally, the big challenge here is how to validate these workflows. So I'm going to actually take the question from an echo, and this final part of my presentation was to show you around the niPreps organization and the website. So before we dive into this on the how to contribute, is there anyone who wants to make any questions?
Yeah, actually, I think we have quite a few questions. So we can start for the first one. So in the middle of the talk, Cesar asked, but acquisition technologies and methods are changing, improving day after day. Some of these tools require adapting the preprocessing beyond the standard. Should we stick to pseudo-fixed preprocessing or be flexible and adaptive in the search of data? Can you comment on that and the evolution of these tools?
So let me search for the tool. I want to make sure I understood the question. So Can you repeat it? I don't see it.
I think you can see it on the, if you push in Q&A. It's the first one. Yeah.
Okay, the first one.
That's
okay.
not better.
Yes, of course. Certainly, the idea for these pre-processing tools is they are thought to be stable, in the sense that they try to cater to the people, for the people that are right now running not the cutting edge kind of Fmri or DMRI. So basically, this is for established projects, and the direction we're taking is, for example, we have a program called long-term support, which is some kind of excision from Fmri. The idea is that we're gonna cut a special release of Fmri called long-term support, which will not have any kind of important change inside, only bug fixes. This way, you can basically pin this version for the length of, for example, 4 years project. Then, for people who are working right now at the cutting edge, the bleeding edge of the technology, developing, for example, multi-echo Fmri. Right now, Fmri doesn't support a multi-echo Fmri in full. It tries to process it, but I don't think the workflow at this point is solid, I would say, or probably you are better off not processing multi-echo with Fmri. But there's a lot of work in implementing multi-echo within Fmri. And this is going to improve as the multi-echo kind of acquisition establishes itself, because it's very new. So this is more of a social process. The bigger the community is, the more needs it has, and the more members that can carry out this, putting the workflow into the current date and updating it with the new features, right? So the principles are for stable pre-processing, but they are thought to be a solid base for people working with cutting edge MRI or other imaging technologies.
Fair enough.
Yep, okay.
I think probably Cesar is satisfied with the question, with the answer, sorry. We can pass to the next one. What would you recommend to someone who trusts and uses open tools like Fmri Prep, but doesn't want to fall behind on the methods? What's a good way to get to know the methods you can use in the library?
Okay, I guess this steps very closely to what Cesar was asking, and I might have partially answered to this. So in principle, the idea is to support established methods. Okay, if you don't want to fall behind, in principle, I don't think there's any problem with Fmri Prep, because the community is already so large. I don't think at some point we will run out in anytime soon, probably in the future, yes, of course, but at the moment, I don't think we will run out of hands to, implement new methods. And the idea of limiting everything within the realm of pre-processing is that there are not so many changes that you need to do in the end. Multi-echo Fmri is roughly the same as the single echo. You need to modify the workflow in some stages, but the changes are not like impossible. They are pretty easy, actually. So usually the methodological breakthroughs happen somewhere else in the methodology or in the sequence. And yet the basis of image processing are still the same. So registration algorithms will be registration algorithms. So in the end, these pre-processing tools would be a good framework to start building new methods. So it's actually easier that you keep up with the growth of the literature and the methods body if you stay with this kind of tools.
Nice. I'm gonna link the next question with another one. So the next question is, how can folks contribute to niPreps? And there is also a question that, are there any niTransform projects that folks can join and contribute to? So I think these two are kind of related in the end.
Yes. So about contribution, I think I will put it after we finish this round of questions, because that's exactly what I wanted to do for the end of the talk. So I want this final stage of the talk to be very dynamic, and so please cut me whenever you have a question. And then if we can finish with the other questions, what was the other question? What of the projects are open for contributions? All of them?
Yeah, in niTransforms, but I suppose in others too.
Yeah, yes, any project. niTransforms is probably the one in more need because it's new, it's very fundamental, and we've been working without it for a long while, so everything is in place to work without it, but we want to push it forward to complete niData, right? So niTransforms looks to me like a very nice. Also, the code is still not very big, so that makes it contributing a lot easier.
Yeah. And related to this, do you think you need any specific profile to contribute to niTransform? Because I saw a question in the chat about that.
Yeah, no, I don't think so. Obviously, having solid foundations about image registration and spatial transforms is important. And having knowledge about data formats would be also interesting because we are using more and more this HDF5 kind of file, which is a particular way of structuring data. But in general, I don't think there's anything impossible to learn, and the code at this point is easy enough for a beginner to start playing with.
Okay, thank you.
How long do you think you want to take to go through the kind of like
10 minutes?
of it? Okay.
Okay, let's do something. Let's go for the thing you want to show us now, and if there is enough time, we can answer the rest of the questions. Okay. Perfect.
Okay, sounds good.
Let's have a look at it.
So the 2 points to start, if you want to get involved and contribute to niPreps, are the niPreps website and the niPreps GitHub repo. So, okay, I don't know if this is actually working. Okay, this is the niPreps website. Most of the concepts I have introduced are here. So I want to invite you to come to the community section, and there's this welcome message. Basically, it tells you a bit about the story and how we started in Neurostars and why it's been so fundamental for us to all the contributions from people outside the walls of the Jordan Hall in Stanford. And concepts very related to things Stefano was mentioning before, how this community building will expose the software, and some of the principles of which that we abide by. Then you will see that we have two kind of roles: active developers, who are people carrying out the daily work of putting more code up and managing contributions, etc., etc. And then we have contributors, and any kind of contribution, as I said, is considered. We maintain lists of these roles in every repo. So you will, if you go to the main/developers JSON file or the main contributors JSON file, you will find these people. And these two files are used to generate these lists I was mentioning before, also to send the metadata necessary for the publication on Zenodo, as Stefano was introducing before. Then we have this, I think this particular section of the website is really interesting for people who are willing to contribute, because new features can be a big issue to software. And I like a lot this initial sentence from Satra. I don't know if the size of the font is okay. I'm going to try to maybe make it bigger. So Satra was expressing his concerns about making Fmri prep work for everyone instead of making Fmri prep work very well in a very defined set of tasks. And this one is about the many options you have, the many knobs you may have in a tool, and how we try to avoid having a lot of knobs that you can fine tune. And this is again related to the feature creep. Is the software engineering concept for when you basically build up things into the software, and in the end realize that your software has too many flaps and too many things moving there that finally make the software less reliable. So Matthias was worried about the futurities case of Fmri prep. This is to say that every time you try to contribute to a big project that has been ongoing for a long while, you need to know that the developers, the maintainers, will need to think it very, very deep before accepting new contributions, because every piece of code you add into a project will require maintenance. So before you try to contribute, you need to think about whether that aligns with the future of the roadmap of the project. And it is very important to have a very fluent communication with the developers to avoid misunderstandings.
No, actually, it's nice that you said talk about this, because sometimes people think like, oh, I think this new feature could be very nice for this project, and they give it to the developers. And it's not that developers are not gonna always accept it, because it takes a lot of time to maintain the library, and you have to select what are your priorities.
Yeah, that only every piece of code you add, it builds up on the maintenance burden. So you need to also know that, and that's important. So that's why here in the website we have this little guide about how we deal with this problem, and how we try to help contributors through the process of determining whether a feature is necessary or not. And then after that, there's a contributing guidelines section where basically we describe some principles of niPreps. So you need to be sure that you really abide by them before proposing any contribution. And this is a little guide about how to use Git and GitHub in adding some code. And for people who want to participate, we have this good first issue label. Sometimes it's also called low-hanging fruit or help wanted. These are labels that we put on those issues that are easy for people for a newcomer to take on. Then we have, of course, tags. We have a new feature requests. And then we have also this other thing. I haven't seen it in many projects. We have this code. We encode some impact of the new feature or bug or whatever request. So maybe there's something broken, very important, that will have a big impact, or there's a comma missing in a plot. that's low impact. And then there is an effort that that particular change will take. So we try always to take low effort, high impact changes first, if possible. And then this is the guide telling you how to use Git, and some codes for, you know, whenever you have to send what we call a pull request, some guidelines to write it, and some style. Finally, we have a code of conduct that basically is copied from somewhere else, but important to have, as Stefano was mentioning. And now I want to come back to the previous slide. I don't know if I will be able, but I can write it here. Oops, maybe not. No, it doesn't allow me. Okay. Do you see a new tab?
Yes, we do.
Okay. So here there is the organization, and there is an overview in this tab here called projects. There is an overview of open lines of work, and we have one particular of Fmri prep, one particular of DMRI prep, and one in general shared across projects. So if you go to the Fmri prep, for example, development roadmap, you can see some tasks we have lined up with the eyes on the next release, 20.3. This is a list of things you can take on. You can see here the label. So this one, for example, has help wanted. There is this one in progress right now happening. We have some maintenance work in this column here. These are typically bugs we need to fix. And there is a developer backlog and then some other issues we want to take a look and think whether we will undertake them or not. And yeah, basically these are the main starting points. Drop me an email or raise your questions on Eurostars. I'll be happy to work. We are a team of people happy to answer, and we will try to show you the way, the most efficient and nice way we can think of. Thank you so much for attending, and yeah, if there's a few seconds we can use for questions,